All right, this is the third and last video for chapter 5.1. These are these last four problems where it's talking about the first two problems are rewriting, then the last one leads us into verifying identity. So this wants us to rewrite the expression so that it is not an expression fractal form. So in other words, so it's not a fraction. Anytime, I'm going to write it over here. Anytime we have something like this where we have variables, or in this case where we have these, the sum of two trig values. One of the ways we can kind of work through this is to multiply it by its my dog's whining. By the what do you call it? My dog's freaking me out. Sorry. The conjugate. God, blanking on that word. So we multiply this by the top and bottom by the conjugate. Secant x minus tangent x. Secant x minus. So this is a conjugate. We're multiplying the top and the bottom by the conjugate. When we do that, on the top part here, we get 5 secant x minus 5 tangent x. On the bottom here, when we multiply those together, we get secant squared x minus tangent squared x. Okay, that's what happens when we multiply by conjugate, and we want that. And the reason we want this secant squared x minus tangent squared x is, again, if we come down here, I started writing it out. If we have our Pythagorean identity right here, and I come in and I divide everything by cosine squared x, cosine squared x, cosine squared x. I divide everything by cosine squared x. Well, here I'm going to get tangent squared x plus 1 equals secant squared x. All right. Now I could rewrite this. I can rewrite this as tangent squared x minus secant squared x equals, that equals -1. Oh, that's right, because sorry, I should have done this a different way. I should have brought, because I want this to be secant minus tangent. So what I'm going to do is I'm going to actually subtract tangent squared x from both sides. That gives me what I want, which when I do that, it gives me 1 equals secant squared x minus tangent squared x. Okay, so we have to know our Pythagorean identities, but we also have to know how to manipulate or change, not manipulate, but change around them to fit with what we need. So if secant squared x minus tangent squared x equals 1, then that's great. Then this at the bottom, the numerator equals 1, so I have 5 secant x minus 5 tangent x. So I've done what it asked. All it wanted me to do was to rewrite it so it's not a fraction. So I've done that. Okay. Use a trig substitution. Use trig substitution to write the algebraic as a trig function for theta. Theta is between, basically everything's going to be positive. So it's saying it's in the first quadrant. So I'm going to take this value here, 2 cosine theta, and I'm going to substitute it where that x is. So I'll rewrite the problem. 64 minus 16 times 2 cosine theta, all of that squared. So that gives me 64 minus 16. 2 squared is 4. Cosine squared is cosine squared theta. Make sure you get all your little bits right here. You got to remember all your algebra. So I have 2 times cosine theta. These are separate terms. So I'm going to 2 squared is 4. Cosine theta squared is cosine squared theta. Okay. Let's see. Now I have 64. Let's see. 16 times 4. Isn't that 64 also? Yeah. Minus 64 cosine squared theta. Okay. Because I just multiplied this in here. All right. So if I have that, then I could factor out, since they both have 64, I could factor that out, and I get 64, and I have 1 minus cosine squared theta, because I factored out the 64. Now, 1 minus cosine squared theta, that's sine squared theta. So now I have square root of 64 sine squared theta, which is the same as saying the square root of 64 times the square root of sine squared theta. Square root of 64 is 8, and it's positive because I'm in the first quadrant. And then the square root of sine squared is sine theta. And that's my answer. Okay? All right, these last two are verifying identities. And we're going to get to 5.2 is all about verifying identities. And so I don't know why we're asking you to do it right now. We haven't gone through it. But here's an important part of verifying identities. Pick one side of the equal sign or the other and work that one. You don't cross the equal sign. You don't work both sides of it. You pick one side, work that side. And typically, you work the more complex side. So we're basically going to get this side here, all right, to look like that. So how are we going to do that? Well, let's see. I can... I could multiply, let's get a common denominator. So I'm going to multiply basically here, I'm going to multiply this by sine theta over sine theta. And I'm going to, over here, I'm going to multiply this by, this side by 1 plus cosine theta over 1 plus cosine theta. You can't really see that. That's a dumb way to do that. But anyway. When I do that, I get sine squared theta, sine theta times sine theta. And then on this side, I have cosine theta, because cosine theta times 1. And then plus cosine theta times cosine theta is cosine squared theta. And all of that is going to be over the combination of these two, right? Because I multiply these together to get a common denominator, which is sine theta times 1 plus cosine theta. So, I mean, that's basic algebra. Hopefully you understand that. I know I made it a little bit ugly looking, but see me during student support if it doesn't make sense. Okay, let's see. I have sine squared theta plus cosine squared theta. Those equal 1. So I can just make them 1 plus cosine theta. The bottom I'm just leaving alone for right now. Oh, look at this. I have, because this is sine theta times 1 plus cosine theta, not plus. If it's plus or minus, I couldn't do anything. But since it's sine theta times 1 plus cosine theta, it is okay for me to cancel this and this out. That leaves me with 1 over sine theta. And the reciprocal property says 1 over sine theta equals cosecant theta. By the way, this whole time I should have been doing this. Okay, that's typically how we do this. Until we get down here where they actually do equal each other. And I put a little check mark here that says, check, they equal each other. Okay. Last one. Do the same thing. Okay, multiply both the top and bottom by on this side, getting ahead of myself. On this side, I'm going to multiply it by 1 minus sine theta, 1 minus sine theta. On this side, I'm going to multiply it by cosine theta over cosine theta. Okay, so when I do that, I get sine theta minus sine squared theta, okay, that's for multiplying this times that, minus cosine squared theta. All of that over cosine theta times 1 minus sine theta. That's my common denominator. All of that equals negative secant theta. Okay. Let's see. this is, let's think of this, let's think about this a little bit, how this is. And you could, some of you just will look at this and kind of know it, but this is basically saying sine theta minus sine squared theta plus cosine squared theta. So I basically just sort of factored out this -1. Okay, so this equals that. And it's important I did that way. Cosine theta 1 minus sine theta equals negative secant theta. Okay, now this equals 1. So sine theta minus 1 over cosine theta times 1 minus sine theta. Okay, equals negative secant theta. Now, these two, sine theta minus 1 and 1 minus sine theta, they cannot cancel out. Don't just cancel them out. Those are not the same values. Okay, that's important here. They're not the same value. It has to be exactly the same. See if I can make this disappear. Oh, come on. Okay, I'm just going to leave it alone. Don't want to ruin it. Okay, so I need to do something so that they do look like that. In other words, the one has to be positive and this has to be negative. So in essence, I'm going to, this can be rewritten as negative, let's do this, -1 plus sine theta cosine theta 1 minus sine theta equals negative secant theta. If I factor out a -1, kind of, in essence, is what I'm doing. This is going to be 1 minus sine theta. Hopefully that makes sense. Just algebraically, that's what I have to do. Okay. And then these two now cancel out, and it leaves me with -1 cosine theta equals negative secant theta, and so negative secant theta equals negative secant theta. Check, and I've proved it. Okay, I need to show all the steps. I need to have the equal sign. I need to have the negative secant. It should look, I mean, I'm really sloppy in my writing, okay? But I have all the steps in there. I'm showing the different steps. I'm showing what I'm doing. I expect to see this when you do any kind of assessment or any kind of work. We don't have to skip. I shouldn't go. You can't go from like here to here without showing some of those steps. Okay, you will not get full credit unless you show these different steps of what's going on. You have to show me